So we're back with this problem and still trying to figure out the null alternative hypothesis. So we know that the CEO claims that it's 80%, and we assume that to be true unless we can prove it otherwise. But then they say that we sampled customers and 73% said they were satisfied. Based on these findings, can we reject the CEO's hypothesis that 80% of the customers are satisfied? Now notice they're not giving us a direction. They're not saying less than 80% or more than 80%. So we're going to say not equal to 80%. They're just saying, can we reject it? They don't care which direction you reject it, just can you reject it? All right, so that's your null and alternative. Step 2, you need to have typing going on. There we go. Step 2, you need a level of significance. Alpha is, there, they gave it to you, 0.05. Right? There's your alpha. Like I said, almost always they'll give it to you. I just didn't do it for that first one because I wanted you to see. I mean, real statisticians, they make it up themselves because they need to for whatever reason. All right, step 3. We need our test statistic. Let me go back and find the formula for that because I don't feel like typing all that up. Oh, hold on one second. There we go. Okay, I had the old data in here, so bear with me. All right, so what was our p hat? Our p hat was 73. Our p0 was 80. Oopsie, 0.80. So that means down here I need to make this 0.80, 0.8 if you will, 1 minus 0.8 because that's what he has claimed to be true. How many people did we test here? Okay, the SIPPAT surveyed 100 customers, so that's what we're going to have for our N, 100. All right, and now let's go find this with Excel. We don't want to do this by hand, right? Or you could use StatCrunch, either way. Pick one. Okay. And the beautiful thing is that once I have this set up then I can kind of use it to help me. So I know this was 0.8 for my problem. I know this was 100. X I don't really care about. They didn't really give it to me. I mean, if you want to leave it there, you can. But they did give us p hat. It was 0.73, which makes sense. It should be 73 out of the 100 customers. All right, then Z0 is right there. It's negative 1.75. I already have it. Let me click on it so you can see. It's that giant formula that we found last time. I mean, the glorious thing is once you set up a spreadsheet to do this, then it'll keep doing it correctly from then on, right? Okay, so negative 1.75. Step 4. Since this is the p-value method, let me go to my editor here. All right, so since this is the p-value method, this is now negative 1.75, what we just found. Okay, and then I got to find the p-value with Excel or with the StatCrunch. Now the kicker of this is that this is with a two-tailed test. Because we said it was two-tailed, that's going to change how we find the p-value slightly. Okay, so the p-value is equal to the norm dist, just like before, but this is only for a one-tailed test. So you have to multiply it by 2 for a two-tailed test. What you can do if you want to set up a spreadsheet like this is you can say p-value left-tailed, if it's a left-tailed test, which is what we found before, and then p-value right-tailed if you like, and then a p-value two-tailed. It won't really work like that. I take it back. P-value two-tailed. Because, well, there's a reason, but suffice it to say that you want 2 times norm dist, and then the same things as before. Negative 1.75, mean of standard deviation is 0, standard deviation of 1, true. Oops, don't press that at the end. And there you go. So it should be 0.08. Now, just on a side note, could we get that from StatCrunch? Let me go up here and type 0.08, just FYI. I'll copy and paste the whole thing into our spreadsheet. Okay, let me go get it out of StatCrunch just to show you. So you go to StatCrunch, you go to Stat, Proportions, One Sample, Summary. We had 5 out of 100, oh, 73, sorry, 73 out of 100. Next, we were testing against 0.8, and it was a not equal to. Calculate. Negative 1.75, see it right there? And there's your p-value, 0.0801. Very fast. Love StatCrunch.